said we should find the modal class. Anytime you hear the word modal, it means highest frequency. Mode is a friend to frequencies. So any class or any group of numbers or any number that are called highest in that particular concept is the mode or the modal class. Just like if you come to this our table, you discover that these are the frequencies. The class that has the highest frequency has the frequency of 13, and that class is 390 to 399. If you come to the graph paper, it is going to give you 395 385.5 to 395.5. That is the modal class, the class with the highest frequency. If you come to your graph paper, it will be the bar that is longest. If you come from your table, it will be the frequency that has the highest number. Whichever way you want to go, you can find your modal class. I'm going to bring the camera close to the graph paper so as to show you how to pick the modal class from the graph paper. Although the bars of the histogram has been cleaned, so we can only see the frequency polygon. Right from there also, the peak of the graph started from here, went up. So the highest, the bar or the class interval that gave this highest, which is 389.5. So we can write it down. 389.5 to 399. You got this from the histogram of your graph paper. Whereas you got the first one on top from your frequency distribution or frequency table. Both of them mean the same class interval, and that is the modal class that the question has asked on question number E. And that has brought us to the end of this question on our frequency distribution, histogram, and frequency polygon. Estimating mode from histogram. You can recall our previous questions. I taught you how to draw a histogram from a distribution like this. In that same question, or in the our previous practices, I taught you how to calculate mean. Now, I have chosen this question to teach you how to calculate mode. Remember, in that previous practices, I taught you how to calculate modal class. But in this case, I want to teach you how to calculate mode itself. The question we have picked says, from the table below, this table, of approximated heights of 30 students, taking class intervals of 135 to 144, 145 to 154, etc. Question A said we should construct the table of frequencies. You know how to do it. I've taught you that. We're going to repeat it now. Question B said that we should calculate the mean height. We're going to calculate the mean. I taught you how to calculate mean in our previous practices. But the reason why this question has come is question C, where it says that we should calculate the mode, not the modal class. I have not taught you how to calculate mode, so pay acute attention and understand how to calculate the mode of distributions in this form. We're not going to waste our time. We'll go straight to question number 1. Sorry, question number A, which said that we should construct the table of frequencies. The examiner in this contest decided to call it table of frequencies. The name can also be distribution table. It can also be frequency table. They have decided to call it table of frequencies. They should not confuse you. They are talking of the same thing. Now the first thing, we take the first class interval, which is 135 to 144. 135 to 144. Pick your paper and your Bible. Go to the table. Begin to sing to yourself those class boundaries that makes the first class interval. Here you know that this is 135 to 144. Go inside there. 135 to 144. This is more than this. 135, 144. 35, 44. 35, 44. 35, 44. 135, 144. 35, 44. 35, 44. You can see that this is among it. So just put a mark under it. 135, 144. 135, 144. This is among them. 135, 144. 135, 144. 135, 144. This is among them. 135, 144. 135, 144. 135, 144. This is also among them. 135, 144. 135, 144. Now that you have marked the members, just count it. 1, 2, 3, 4. So go there and write. The first class interval has 4 members. Now that I've written the members of the first class interval, what you do, all those members that you marked, clean them. So that when you mark other ones, or you use another thing to show the members of the second, so that when you be counting, the mark we are going to use in detecting the members of the second class interval will not be stroke under again. It may be stroke on top, or stroke by the side, or crossing it, so that you'll be able to know. You know that if you use the same sign of stroke under, you might, when counting, also count and include members of first class interval. I can find out error will flow in. So let's go. We have 145, 154. You can call it 45, 54. You know that it's 145, 154. So let's go by 45, 54. 45, 54. This is among them. You can cross it. 45, 54. 45, 54. This is another one. 45, 54. This is another one. 45, 54. 45, 54. 45, 54. This is another member. 45, 54. This is a member. 45, 54. This is another member. 45, 54. Another member. 45, 54. 45, 54. This is a member. 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 45, 54. This is another member. 45, 54. 45, 54. That is all. Now count how many you crossed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That means there are 12 members of the second class interval. We cannot continue. I have taught you how to pick the members of a class interval. Now, when next you see the whiteboard, we must have taken the members of 155 to 164. Then 165 to 174. This is the last class interval, because if you look at the values you have here, none of it is more than 174. So when next you see the whiteboard, I must have written down the members of the remaining class intervals. Now that we have finished assigning the members of all the class intervals, the next thing you do to be sure of the members of class intervals you have assigned to the class intervals, find the sum of those members. They must give you the number of students that their heights we are taking, which is that 4 plus 12 is 16. 16 plus 8 will give you 24. 24 plus 6 will give you 30. This shows that what you have done here is correct. So the next thing now is construct the table of frequencies, which question number 1 is actually asking for. Very simple. Write class intervals. Frequencies. You know, you have 1, 2, 3, 4 class intervals. So divide this into 4. The first class interval is 135 to 144. Second is 145 to 154, sorry. The third is 155 to 164. The last is 165 to 174. The first has 4 members, second 12, third 8, fourth 6. You have finished question number 8. The next thing is we're going to clean off this and do question number B. Now let's do part B of the question, which said that we should calculate the mean height. If you want to calculate the mean height, the first step you take, that means you want to answer question number B. First step, choose an assumed mean. Choose an assumed mean. Go to the frequency distribution table which you calculated in question number A. Go towards the middle. Now you have the first class interval, the second class interval, the third class interval, and the fourth class interval. Between the second and the third, choose the mid value of any of the intervals, either in the second or the third. Let's take the second. The mid value is going to be 145 plus 154 divided by 2. 145, which is the lower class value, plus 154, which is the upper class value, divided by 2. It will give you the mid value in the class interval. We are going to use it as what we call assumed mean. Let's find the value. 145 plus 154 is giving us the divided by 2. It's giving us, so our assumed mean $149.5. That is our first step. Second step, take the mid values of all these class intervals to represent the class intervals. Take the mid values of all these class intervals to represent the class intervals. That means the first class interval will be represented by 135 plus 144 divided by 2. 135 plus 144 divided by 2. First class interval will now be 139.5. Second class interval was where we got our assumed mean. So the mid value will be 149.5. The third 155 plus 164 divided by 2. This is giving us 159.5. This one will give us 169.5. It is in this sequence. The third step now. Third step. Begin to subtract all these values. Subtract the assumed mean from them. So this place you have minus 149.5. Minus 149.5. Minus 149.5. Minus 149.5. The representatives of the class intervals which we took to be the mid values. Subtract that your assumed mean from each and every one of them. This is going to give you, after subtraction, minus 10. This is going to give you 0. This is going to give you 10. And this is going to give you 20. You can confirm using your calculator. Now, the fourth step now. Fourth step. Begin to multiply all these values you got by subtracting the assumed mean from the representatives of the class intervals, which are the mid values of the class intervals. Begin to multiply them by their respective frequencies. So here you have the first class interval have the frequency of 4. So you have minus 10 times 4. The second class interval has the frequency of 12. The third has the frequency of 8. The fourth has the frequency of 6. Whatever it gives you, just on. So now the fifth step. Fifth step, multiply out. 4 times minus 10 will give you minus 40. 12 times 0 will give you 0. 8 times 10 will give you 80. 6 times 20 will give you 120. Now the sixth step. Let me continue it here because of space. We no longer have space over there. The sixth step. Find the sum of these values. Add these values together. 80 plus 120 will give you 200. Minus 40 will give you 160. Plus 0 will remain 160. So we have 160 as the sum of these values that we got by multiplying the different frequencies with what we got on the frequencies by reducing the assumed mean from the representatives of the class intervals. 160 is what we got. This value we got now divided by the sum of the frequencies divided by 30. the sum of the frequency, the number of students that participated. If you have 160 divided by 30, it's going to give you, you can cancel this. 3 divided 16 will give you 5, remaining 1. Put point and add 0 to the 1. 3 divided 10 will give you 3, remaining 1 again. Add 0. 3 divided 10 is 3, so it will keep occurring. So you can leave it at the 4th decimal place. Now the 7th step, which is the supposed last step on the processes of finding the mean. The mean is really hiding somewhere. It took 7 steps to find it. Okay. The 7th step now says you should add this value to the assumed mean. That means you have 149.5, which is the assumed mean, plus this value, 5.3333. Let's do the practical arithmetic. It used to be very sweet. Let's abandon our calculator for now. Let it not be as if we don't know what we are doing. That we are allowed to use calculator in our exams hall does not mean that if they did not tell us to use it, we still make A in mathematics. We have something here. Alright. 0 plus 3, 0 plus 3, 0 plus 3. 5 plus 3 is 8. 9 plus 5 is 14. Raise 1 plus 4 is 5. 1. This value now is that your hidden mean. You can see the levels of investigation that it took. 7 steps, 7 investigative steps was what it took us to discover this criminal called me. And that has brought us to the end of question part B. Now, the main cocoa question part C that says we should calculate the mode height. We're going to clean up. We're not afraid of it. That one is an armed robber, while this was just a robber. We will apprehend him by some technical investigation. But that will be when we clean up this so that we have enough space for him. Now, question number C that said we should find the mode height. We are going to really use our graph paper. Draw the histogram. Dictate the modal class. Do some blah 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 on the modal class and find out the mode from there. But before we go down to our graph paper, I want to illustrate how to find the mode from the graph paper. We'll keep finding. We are now investigators, just like the FBI in America. FBI is equivalent to the SAS, Special Anti-Robbery Squad, that we have in Nigeria. I was browsing the internet the other day. I discovered one software, one format Americans have detected. And I discovered that Nigerians there call it, you can run, but you cannot hide. And the FBI will always tell you, you can commit crime and disappear from the environment, the place you committed the crime, but you cannot hide. I wonder how they are doing it. But that is by the way. So, had it been, for instance, this is your graph. You plotted your graph and you got your histogram, and your histogram is in this form, for instance. You know that histogram does not leave space in between the bars. Assuming your histogram is something like this. Have 1, 2, 3, 4. 1, 2, 3, 4, 5. Don't worry, I'm just using this as an illustration. Your class intervals are here. These are your class intervals. Whereas this is going to be the frequencies. Frequency is the y-axis, class interval is on the x-axis. Okay, so this is your histogram now. If this is your histogram, you discover that the class that has this highest or the longest bar is the modal class, isn't it? That is the truth. Now this modal class, if you want to find the mode, is simply draw and join the vertices of these related rectangles to the rectangle of the vertex of the modal class in this form. When you do this point of intersection, read the value you have on it down on the x-axis. Whatever value you have here is the mode. So this is the illustration of how to find modes in a grouped data. Now we are going down to our graph paper. I'm going to paste the graph paper here and really practically do what I have illustrated so that you will really understand. Now this is the graph paper. That is the graph paper. First of all, let's go up. A histogram to estimate the value of the mode using scale 2 cm to the width of the rectangle on x-axis. The width of the rectangle is on x-axis. This is the first rectangle that stopped at 4. This is the second rectangle that stopped at 12. This is the third that stopped at 8. And this is the last one that stopped at 6. Now the scale went ahead and said 2 cm to 1 unit on y-axis. That was why this y-axis was calibrated. From here to here is 2 cm, and in between all the squares you see 1 unit. That's exactly what it meant by 2 cm to 1 unit on y-axis. And it's calibrated from 0 through 12. Now the first class interval we have is 135 to 144. As I told you that a histogram should not have any gap in between them. That was why that first class interval was reduced to 134.5 as against 135. So just subtract 0.5. So you now have 134.5 to 144.5. Remember, the upper side of the class interval there is 144. So when you reduce 0.5 from the lower class value, you gain it from the upper class value. That was exactly what we did here. 135.5, we have reduced 0.5 from 135. That now gave us 134.5. And we came here, instead of having 144, we now had 144.5. So that 0.5 we lost here, we gained it here. And that was why there are no gaps in between our bars. Okay. The x-axis is the class interval axis, the x-axis. The y-axis is the frequency axis, the y-axis. Now, the first class interval has frequency of 4, and that was why the rectangle of it stopped at 4. Look at where the rectangle ended. The second class interval has frequency of 12. Frequency of 12. That was why the second bar here ended at 12. Look at where the second bar ended. The bar of the second class interval of 144.5 to 154.5. The third class interval has frequency of 8. That was why its bar, the third bar, 1, 2, 3, stopped at 8. The last but not the least, the fourth class interval of 165 to 174, which in the graph paper is turned to 164.5 to 174.5. The frequency is 6. The frequency is 6. So that was why its bar ended at 6. Ended at 6. Now the mode. If you look at this histogram now, you discover that the rectangle that is longest is the modal rectangle, and it represents the modal class, and it is the second one, the second bar that ended at 12. So this is the modal rectangle, or the modal, and this class is the modal class. If you also come to the table of values or the frequency table, you discover that it is the second that has 12, and 12 is the highest frequency we have in that concept. So now, to calculate the mode, or to estimate the mode, because it is an estimation, this first rectangle stopped here, the modal rectangle stopped here, and the next one to it stopped here. So we are going to join these vertices of the rectangles. Join this point to this point, and join this other point to the adjacent point, or the opposite point, sorry. So when you do join, the two lines you have joined from here to here, and also from this side now to this side, they will intersect somewhere. So when they intersect, you now read or draw a line down from the point of intersection and meet the axis, and now read the value you have there. Whatever the value might be is going to be your mode. Now I am going to draw the intersections. When next you see this graph book, I must have drawn and joined the vertices of the neighboring rectangles to the rectangle of the modal class. Now you can see that we have joined the vertices of the modal class rectangle to its right and left neighboring class interval rectangles, as you can just see. We joined here to here, and joined this place to this place. You can see that the two lines intersected here. So we are going to draw down this value down until it meets the x-axis. So when next you see it, I must have drawn that point of intersection down to the x-axis. Then we will now read the value we have there. You can see now that I have joined the point of intersection of the two lines
point of intersection of the two lines that we drew from the vertices, and I've joined it straight down to meet the x-axis. Now what is remaining now is for us to read the value. This is 144.5, this place, and this is 154.5. That means from here to here is 10 units. So if from here to here is 10 units, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 small squares, that means each of the small squares is 1 unit. If that is the case, that means here is, if here is 144.5, that means here will be 145.5, 146.5, 147.5, 148.5, 149.5, 150.5. But this line came in between 150.5 and 151.5. That means here now is 151 at the dot. The value we have here is 151 at the dot. Let me repeat what I said. This place is 144.5, this place. And the difference between this place and this place is 10. If you subtract 144.5 from 154.5, you get 10. So if here to here is 10 units, that means as long as we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 small squares in between, that means each of the small square is 1 unit. If that is the case, if here is 144.5, that means here will be 145.5, 146.5, 147.5, 148.5, 149.5, 150.5. Then this should be 151.5. So now that it is in between them, that means this place is 151, and that 151 is our mode. So you just come down here and write mode is equal to 151. And that has brought us to the end of that question.
We have entered into a brand new topic in our statistics. We are progressing gradually, and I know how or why I'm taking it gradual, so that you will all be taken along. The topic we enter now is cumulative frequency, quartiles, percentiles, and median. I would like to take the explanations of these subtopics one after the other. First of all, the cumulative frequency. Cumulative frequency. Just as the name implies, you know what frequency is. The occurrence of a particular event. Cumulative frequency is talking about when the frequency is accumulating. And the accumulation, as will be related to this topic, is on the sums. For instance, if you come to this table that we have here, these are the frequencies and these are the class intervals of maths. The first class interval have frequency of 2, second half 5, third half 11, fourth half 20, and it went down, the last half 3. The cumulative frequency of this adventure is when you use 2 to represent the first class interval, then the second will be represented by 2 plus 5. The third will be represented by whatever you have gotten from 2 plus 5, then add it to 11. The next will be represented by whatever you get by adding this, and this, add it to, and in that progress. That is what we call cumulative frequency. When the frequency is being added, and whatever their sums are, you keep adding them, and using them to represent the equivalent class intervals. That is what we call cumulative frequency. When we go into solving problems like the one we have on the whiteboard, you're going to understand what I have really explained about cumulative frequency. We have finished about the discussion of cumulative frequency. Let's talk about quartiles. Quartiles are when these cumulative frequencies are divided out into 4 sections, 4 equal sections. Each of the section is called a quartile. When the cumulative frequencies, remember when you progressively add the frequencies, just as I had explained, at the end of the day, the last sum will give you the sum of the frequencies. That means it is 100% of the frequencies. Now, when you divide out that 100% of the cumulative frequencies into 4 equal sections, each of the section is called a quartile. That means the quartiles comes, we are discussing the quartiles. The quartiles, they come in the first section is the 25th. The second is the 50th. The third is the 75th. And the last is the 100th. So these are the way the quartiles are divided. The cumulative frequencies are divided. The first quartile, which is the 25th, is called the lower quartile. Lower quartile. That is 25th. The formula for finding the lower quartile is 1/4 of n plus 1, where this n is equal to the sum of frequencies. N is sum of frequencies. That means if you get the sum of the frequencies, add it to 1, multiply it to 1/4. Whatever you get is the lower quartile. The second is the semi-quartile. The semi-quartile, that is the 50th quartile. The formula for the semi-quartile is 1/2 of n plus 1, where n is the sum of frequencies. The third is called the upper quartile. That is the 75th. And its formula is 3/4 of n plus 1, where n is the same thing, the sum of the frequencies. In practice, there are other things we are going to meet. We are going to meet what we call the semi-interquartile range, and we will also meet what we call the interquartile range. in most cases, in my experience, I discovered that students used to be confused with these two concepts: semi-interquartile range and quartile range. They are not the same thing. For instance, if at times some authors will represent the lower quartile with, they will